this work? Yes, it works. Spoiler, bite mark. Right, so I'm Sam Beckham, and I'm here to talk to you about Grease Lightning, not the car, but how to make your website load really, really fast as a progressive web app. Now the fancy Twitter thing that Martin was talking about earlier is, this is my Twitter handle, send me a tweet if you have a question. That's as fancy as it gets. This talk was meant to be 20 minutes, but it kind of runs on to about 30, so I'm going to have to skip Q&A at the end. So send me your questions. I'll try and address them at the end if I have time. If not, I'll just reply to you on Twitter, or come find me at the end. So very quickly about me, I work at Bytemark. They're a hosting company. We do cloud hosting. Got to be quick, don't have much time. This is where I work. Frontend is it's an event I help organise. You may have heard of it. You should come along sometime. It's quite good. It's quite local. We're also doing a conference, and tickets went on sale today. But I'm not going to talk about that too much today. Well, I am. So the majority of this talk, I'm going to go through how I took the Frontend website from pretty quick loading speeds to stupid quick loading speeds by converting it into a progressive web app. That's all I'm going to talk about with the conference. I'm not going to go too far into promoting tickets, I mean, they're on sale today for £125, but I'm not going to mention that. I'm not going to mention that we've got Christian Heilman, Leonie Watson and Val Head confirmed so far. I'm not going to mention it at all. How fast does it load? On Wi-Fi, which just means a decent internet connection, it loads in about a second, which is pretty quick. But what does Wi-Fi mean? It can be anything really. So 3G is a better benchmark. 3G we're getting about 3-second loading speeds. The industry sort of benchmark-ish is about 5 seconds to 10 seconds. So 3 seconds is already pretty good. But I'm a bit of a perfectionist and I know I can do better. So after today I'm going to show you how I took it down from 1 second on a Wi-Fi connection to about 0.3 seconds. Now, on average, according to Wikipedia, it takes about 350 milliseconds to blink. So this is literally loading in the blink of an eye. Didn't make that up. Did. 3G, given that we've already got a 300% speed increase on the Wi-Fi, 3G was originally 3 seconds, so you'd expect around 1 second loading times on 3G, but in fact we're getting it at 0.3 seconds as well. So again, around the blink of an eye. So we start to look at some slower speeds to maybe start getting a slightly longer loading time, but it actually doesn't matter. The loading speed's the same whether you're on Wi-Fi, 4G, 3G, 2G, Gina G, all faster than you can blink. What's more impressive is offline, instead of getting this little dinosaur game, unfortunately you do get our website. Which is a bit odd. A website that works offline kind of seems to go against what a website is. And that's because I made the website into PWA, or a progressive web app. Now this is sort of something Google have come up with. It's a term that basically means that it's a website that acts and behaves like a native app. So it is just a website, but you get some native app-like functionality, like the ability to install it to your home screen, loading offline, which is where we get all the speed increases, because it's just loading from your device. If it's loading offline, you don't need the network speed doesn't matter. You can also receive push notifications. I'm not going to go over how to do this because I don't know how to do it. But you can do this, and there's some other things as well that really make your web app feel like a native app. But my favourite thing about it is that it is built in HTML, CSS, and a really, really tiny bit of JavaScript. So it's just a website. There's no fancy pants frameworks. You don't need React Native. You don't need React, Angular, anything. You can use React or Angular if you want to, because it's just a website. So anything you can use on a website, you can use on this. There's no compilation processes, so it's not like PhoneGap or Cordova or any of them. It's just a website. It is just a website with a little bit of JavaScript that lets you install it to your home screen and does all the other nice native app type things. Now I put this at the end of my slides originally, but I didn't want to end on a bad note, so I've put it in the middle, a little bit of a disclaimer. It does not work on iOS. Unfortunately, the service worker, which is like the main part of this, is not supported on Safari, which means iOS you can't use it on iOS basically. There is Chrome for iOS. Chrome for iOS is Safari with like a Chrome wrapper around it. So if you have an iOS device, sorry. But if you do, I mean, it's a progressive enhancement. It's still a website. You can still go on and buy tickets for the low price of £125. That's not the end of them jokes. Yeah, so you can still go on the website and use it as it is a website, as it's intended. You can do everything. You just don't get the appy type things, you don't get the speed increases, but nothing breaks. It's still a fully functioning website. So that's the end of my disclaimer. Let's go into how we actually, how we build this, how we start doing this. I'm going to use a program called Lighthouse. Now I know previously I said we weren't going to use any frameworks, and you're probably thinking, wait, you said no frameworks, that's you just now. But it's just a list. It's just a list. It's this list. So what Lighthouse does is it's a series of tests, kind of like end-to-end tests, and it runs against your website, and it says, does it have all of these things? I'm going to go through each one of these individually, but there is an npm module, so you can run Lighthouse in your CI. There is a Chrome browser extension, so you can navigate to a website and run this Lighthouse test against. You can run it against any website, you don't even have to be developing on it. And because of the popularity of the Chrome browser extension, it is now built directly into Chrome DevTools as of version, I'm going to say 60. Might be wrong. I'm going to show you the Chrome DevTools way to do it. So hopefully this video is playing behind me because it's not in front of me. Hey! So we open DevTools, go to the Audits tab, and you get the little lighthouse. We perform an audit, and it goes through and it does some various things like turns off JavaScript, reloads a page, throttles the network speed, reloads a page. It does all sorts of bits and pieces. Looks pretty weird, but there we are without CSS. And then it gives you like a sort of list here that says, here's everything you failed with, here's everything you've already passed that's on the list, and here's some manual things you need to need to check yourself. And then you can go away, you can tweak them, and you can sort of rerun the test to make sure you're passing the things. And it tells you how to do everything that you need to do. But today that's my job, so here's the list in a sort of more slide-friendly format. And this is all the tests that we ran against the Frontend and E conference website. You can see we've already passed most of them, because a lot of this list is just kind of best practice, really. There's two things on this list that actually failed on the test because I stupidly ran it against localhost, so the HTTPS stuff failed because obviously my localhost isn't a secure enough server for Lighthouse. I'm going to go very quickly through all the things that we've passed, just in case you're trying to follow along. I'm assuming at home on the video, no one's got the laptops out, and you've maybe not passed some of these. So the first thing we did pass was non-JavaScript content. And what this means basically is, does it show some content when JavaScript is turned off? And it, in this case, is your website. Some content just means literally some content. It can be a web page that says you need to turn JavaScript on. Personally, I'm not a fan of that, but that's all it's checking for. the conference website works in its entirety without JavaScript, but it's not a complicated website, so it's maybe a bit easier. Fast enough on 3G is the next thing that we passed. Now, I already showed you how fast it was on 3G. It's pretty quick, it loads in about 3 seconds. All this test is looking for is it interactive in the first 10 seconds? So it's pretty lenient. If you're not hitting this 10 seconds, there's in the same audits tab, there's a lot of recommendations to help you get that speed up to this 10 seconds as benchmark. And then once you've hit that, you can use your service workers and progressive web app stuff to get that down to the sort of 300 millisecond range that we're getting here. The meta viewport tag is something else we passed. If you're doing responsive design, you should be aware of this. It's basically this. I've just written it out twice because I had a feeling you won't be able to see the bottom one, but you maybe can actually. It's the responsive tag that you put in your head. You know, when your responsive site doesn't work and then you realise you forgot to put this in. It's this, that's all it is. There's different variants on it, but this is the one I use pretty much all the time and it works. Size correctly for the viewport is another one we did pass. And again, if you're doing responsive design, it's an easy win. It just means, does your website fit on the screen basically? So are you getting this and not this? If you are failing this, chances are you've got some horizontal scrolling somewhere, so just be aware of that. HTTPS and the HTTP to HTTPS redirect. This is a front-end talk, so use Let's Encrypt or talk to your hosting provider or get a DevOps friend. I'm not going to tell you how to put HTTPS on your website because I don't know. So, what have we passed? I've just gone through what we've passed, so you should know. We've got 5 things left. These are the 5 things that we need to do to get the fast speeds, to get the app on our home screen, to get all sorts of different natively type stuff. So I'm going to talk through the biggest one, and this is what gets us the network speeds and the offline, and that is the service worker. This is incredible, and it's fairly simple in its kind of concept, but you can do a lot with it. And the way it works, in order to explain how it works, I need to kind of go back to the very basics of how a website works. So, oh, my emojis work amazing. So, you've got a browser and you've got a server, and your browser makes a request to the server for index.html, main.css, whatever, and then your server responds with a response to that request, being the actual file that you've just requested. What a service worker does is a bit of JavaScript that sits right in the middle of all this, and it can listen into the requests, it can listen into the responses, and it can do various things. So, for an example, we've got the service worker and the browser and the server, we've installed our service worker, and our browser asks for catpic.png, because every talk needs a cat picture. And then that service worker, by default, passes that request on untouched to the server. The server returns a cat picture straight through to the browser. So it's almost as if the service worker wasn't there. It's just taking that request, passing it through, passing it straight back to the browser, and you get your cat picture. But what we can do is we can modify these requests and we can return our own responses. So the browser can ask for catpic.png, and the service worker can say, well, I already know what catpic.png is, I returned it earlier and I stored it in my cache. So instead of making a request to the server, it just sends you it straight back from its own caches. So we've completely cut the network out at this point because the service worker just lives in the browser. So we don't need the internet basically in order to receive this cat picture on our website. We just need the service worker. So this is why the speed of your network doesn't matter as to how quick your site loads, because you can do the same thing with index.html, you can do the same thing with your CSS files, and it just requests it, the service worker hears it and sends you it straight back from the cache. I also had a slide in here earlier where it would hear any image request and just send back Nicolas Cage in his place. But I had to cut that out for brevity, unfortunately. So, how do we make this service worker? The useful one, not the Nick Cage one. First off, in our main.javascript or whatever JavaScript, it can be in it can be directly in your index page or whatever, however you include your JavaScript. We need to tell it to install or register, your service worker. So all this is if navigator.serviceworker. So if your browser supports the service worker, then we say serviceworker.register, and then we tell it where the service worker is and what scope we want the service worker to have. So you have to put the service worker in your root directory so that it can actually, service workers can only affect things below them. So this prevents things like me writing a service worker that says every time you want to go to Google, redirect to the Nicolas Cage fan club. You can only modify requests made below where the service worker actually lives. So if you've got the service worker in your scripts file, you then can't modify any requests made to your CSS files or anything like that. So long story short, put your service worker in the root of your project. So that's your JavaScript side of it. And then inside the actual service worker itself, what you do with the service worker is it installs itself, and then once it's installed, it activates itself, and then once it's activated, you can listen for fetch requests. So pretty much everything in a service worker is an event, inside an event listener. And the first thing we do is we listen for the install event, and we say, when you're installing, here's what we want to do. And what we want to do is cache a load of files. So as soon as your service worker installs, we open up a cache and we give it this terrible name here. And then we add all of these files to the cache. So we're adding the main.js to the cache, we're adding forms.js to the cache, main CSS and an index page. And this forms.js, it's not even on the index page. So you're going to the index page and it's not requesting the forms page, but the service worker is telling it, I'm going to need this at some point, so put it in the cache. So that's I mean, if you look at this carefully, you'll realise there's some caching issues here, but I'm not going to go into that. I've got a story about that later. Yeah, we've installed, we've put things in our cache. We need to listen to the fetch event. So what this is, in that previous diagram where we asked for the cat pick and it was going through the service worker, so this fetch is saying like any requests that the website makes, let's listen into them on this fetch again. And this is where all the magic and all the dragons live. This is what lets us say, like, if the request ends in PNG, respond with nickcage.png, and you start getting Nick Cage pictures instead of the pictures you want. What we do want to do, which is probably a little bit more helpful, is we say, right, okay, so we've made a fetch, there's a fetch event, and I want to listen to that request, so the request that the website has made, whether that's main.js or whatever, and instead of just sending it off to the server and responding with the normal response from the server, we first say, does anything in our caches match this request? And if it does, then we return that response. If it's not in the cache, then we just fetch the request as normal. This might look a little bit odd if you're not familiar with ES6, but apologies, it makes it a lot easier to fit on a slide. If you do want an ES5, I guess, version of this, just message me afterwards and I'll send you that. And that's really it. That's all we need to do with the service worker. We've got the offline support there, we've got the heavy caching, we've got all the speed increases, and this is it in its entirety. So we listen to the install event, and as soon as it's installing, we say cache these 4 files in this case. You can put whatever you want in there. And then when a request is made, if it's for any of these files, then return this file that we have in the cache rather than going after the network. If it's not in this cache, it doesn't matter, carry on, go to the network. So, for example, if we do ask for index.html and we're offline, checks the cache, it's in the cache, returns it from the cache. Then index will ask for the main JS and the main CSS, and it'll do the same thing, it'll return them straight for the cache. But if it asks for, I don't know, Christian Heilmann's photo, it's not in the cache, so it'll try and fetch it from the network instead. There's issues with this particular service worker, like it will cache all of these files forever, and if you ever change the CSS, no one's going to see that change. So there's ways around cache busting and stuff, and I'll put out some links to an actual useful version of the service worker that has cache busting and stuff in there. But this is the basics. This will get you going. So back to that lighthouse list. If you remember it from before, service worker is now a big green tick, and 200 when offline is also now a big green tick. It basically just means are we returning 200 response rather than a 404. So is the page there when we're offline. Now that's all of the speed increases done. We've got the offline support. I've got everything I set out to do originally. We're loading in 0.3 seconds. I forgot to put a benchmark in, so you're going to have to trust me. I've done everything I set out to do, but looking at the lighthouse list, there's only 3 things left, so we might as well go for a fully fledged progressive web app here and get the ability to add it to the home screen and all that sort of nice native stuff. And the 3 things are custom splash screen, which just means one of these. When you open up Twitter on your phone or whatever, you get that, you get this, and then it loads into the app. So we need a custom one of them. And themed address bar. I have no idea why this is in the list. It makes no sense to me. It's this. So this is my, is it loaded up? Yeah, this is my blog, and you can see I've made the actual browser itself the colour of the post. I don't know why it's needed for this, but it is. And it's really easy to do, so we might as well do it. And both of these things are inside what is called the manifest.json file. And this again sits in the root of your project. And we set some attributes like the name of the web app. So Frontend conference. The short name, this is what will display underneath the icon when you've got it on your home screen. Start URL, so what page on our website do we want to go to when we open the app. Scope, again, just everything. You can scope off a certain site, like part of your website if you don't want the whole thing as a web app. Display standalone just says basically get rid of all the browser stuff when I open it up, so you don't get the address bar, you don't get the back buttons, all that sort of thing. Theme color, this is what changes this bit. I've just set it to grey because it's a nice colour. Background colour also set to grey. Now the splash screen, that like the Twitter splash screen that I was showing you, what it does is it takes the background colour, it takes the icon that you set, and it takes the name, and it just builds a splash screen for you. You don't need to do anything. I think you can get a little bit more in depth and create fancier splash screens, but this will do for the test. And it's on screen for about half a second, so well, not even that, it loads at 0.3, so it doesn't matter too much. So once you've got this file, all you need to do is include it in your head like you would a CSS file or other files. You say it's a manifest file and it's here, and it's this manifest.json, and then you've got custom splash screen, done, themed address bar, done. And we have one thing left on our list, and that is prompted to install the web app. So this just means when the user is visiting your site, do they get a prompt that says, hey, do you want to install this to your home screen? Now if anyone tried doing this back in 2007 when the iPhone first came out, it's really hard. There's lots of ridiculous APIs you need to hook into and do some browser detection and stuff. But luckily it's a lot easier now. What you do need to do is literally nothing. Always a fan of that being the thing you need to do. So Chrome will know, because it'll run through the similar sort of lighthouse checks itself in the background. It'll know you've already passed everything else. It'll know you've got everything you need to be a progressive web app, and it'll sort that prompt out for you. So if you are viewing the conference website on your browser, and maybe you're buying tickets to the conference.
How much of it?
About £125. The low price, special deal. I've lost where I was. Oh yeah, that's right, you were buying tickets to the conference. Yeah, so as you're browsing around, it'll start to realise that, hey, maybe they are interested in this page, and it'll just bring up its own little prompt to say, do you want to install it to the home screen? And you can dismiss it, you can add it to your home screen, you can do what you like. And because it's controlled by Chrome, it's not too intrusive. It's quite nice. So, prompting to install the web app is done really easy. And conversely, everything on this list is now done. We have a fully fledged progressive web app, and this is that web app. So if you go to the Frontend 2018.frontend.co.uk, and you just sort of start navigating around the website. I don't know, obviously I took this yesterday before the tickets were on sale for the low price of £125. Start moving around a bit, hopefully it doesn't flicker when the thing I'm trying to show you actually shows up. It starts to realise that, you know, maybe they are interested in this site because they've been looking around it for a while. Oh yeah, that's right, I've got this in the wrong order. So I go offline, that's what I was showing you, and this site works offline. Everything's loaded in. You can still scroll around, you can go all the various different pages. The forms won't work obviously because you need to submit them to a server, but there's something in there that waits, there's the pop-up. And we add it to our home screen. And, oh Christ. Well, you did add to our home screen there, you don't have to trust me, there we go. So, and you saw the splash screen for a little bit there. That was auto-generated by the manifest file. And you can see it is its own app, it's not actually Chrome. You can close it, you can open it again. We're offline still, we're still doing all of this offline. Yeah, I think that's about the end of the video. There's not much more to show you on that. So that was how to get a progressive web app up and running in, I want to say, less than 20 minutes. Thank you very much.